Hi, my name is Pranay Bakre. I'm a Principal Solutions Engineer at ARM. We are here at KubeCon North America 2024, and we are showcasing a demo at the booth about Twitter sentiment analysis, real-time Twitter sentiment analysis on ARM Neoverse-Based CPUs. An overview of our solution. What you see here is a dashboard that's showing all sorts of different things. What we are doing here essentially is pulling tweets from Twitter using Twitter Developer API based on certain keywords, ARM, Neoverse, etc. And those keywords, we are filtering that data, sending it to Amazon Kinesis, and sending that process data to a sentiment analyzer model, which is a Stanford NLP text classification model, which sets the tonality of or detects the tonality of the tweets based on very positive, very negative, neutral, and somewhere in between. After it's done that, and that sentiment analyzer model is running on an Amazon EKS cluster, which is running ARM-based nodes. So that process data gets sent to Elasticsearch, which is a NoSQL database, which is also running on ARM Neoverse CPUs. And it has a dashboard called Kibana, which is a component that displays the tweets in real time on how they were processed and what the tone of the tweets are. So if you look at the dashboard here, if you see here on the left, we see a sentiment type type for all the records. So since the show started, we have processed around 300,000 tweets. That's a lot of data, and it did it without breaking a sweat. But the main point to note here is that even with this huge amount of data, the CPU and memory usage for those instances still it barely moves up. That's the power of Neoverse CPUs, and we'll get to that in a second. But what we see here is on the right-hand side is in the last minute how many tweets were processed, and on the left-hand side all-time records for the tweets. Now, the reason I mentioned about the usage of CPU and memory is because this is a scalable architecture. You can have, based on the load that gets generated from the tweets and the processing that's required, you can scale the solution based on the requirements in a distributed fashion, and you can implement as a distributed architecture. Now, how do you identify what's the load and how do you auto-scale those nodes? Is we have Prometheus and Grafana as components that are deployed inside the cluster as Kubernetes pods. What it's doing is it's monitoring all those clusters metrics, which you see here is CPU RAM usage. And if you see, there is it stays below the maximum threshold of the capacity. But using this, you can set alerts. If you see that, oh, it's 90% at capacity, automatically another node will get added to serve more requests. And then basically you can scale up and scale down based on how you want to do it. So in conclusion, what we are showing here is using ARM Neoverse, you can build a solution that's much more scalable and much more robust, and then you can deploy this entirely architecture. Thank you.